Now let's talk a little bit more about using equivalent ratios to help us understand problems with ratios. Looking at numbers 1 through 3, we need to find out if these ratios are equivalent. And the easiest way for me is just to look and see what the relationship is between two of the numbers. So I look at 4 and I think, how did 4 get to 2? And I know that 4 divided by 2 is 2. So 4 divided by 2 is 2, so that's how I got to 2. And if I do that, then I also have to be able to do that to the other part of the ratio. I should be able to say 18 divided by 2, but 18 divided by 2 equals 9, not 12. And therefore, these two ratios are not equivalent. Let's look at the next set. We have 5 to 20 and 15 to 60. Once again, I'm going to look at my first set of numbers in my ratio, 5 to 15. Well, that's easy. I multiply by 3. If I multiply by 3 here, then I must be able to multiply by 3 here as well. And 20 times 3 is actually 60, so these are equivalent, so we're going to put yes. And it has a scale factor. That means, what did you multiply it by? A scale factor of 3. Very simple. And let's look at our last one. Okay, so off the top of my head, I do not know 17 times what gives me 68. But I do know that 3 times 4 gives me 12. I'm going to go over to the table or to the side and try 17 times 4. 7 times 4 is 28. 4 times 1 is 4, plus 2 is 6, and that gives me 68. So this is equivalent. And our scale factor is 4. So a scale factor of 4. Very good. Now, we are going to work with tape diagrams and number lines. And we talked about these in our vocabulary, but we haven't worked with them yet. Preston reads for 20 minutes. So he reads for 20 minutes and practices his math facts for 5 minutes each night. Well, there's a ratio right there. After several days, he had practiced math facts for 45 minutes. How many minutes did Preston read in the same time period? A tape diagram is called a tape diagram because when you draw it, it looks like a piece of tape. So we're going to draw out our tape diagram, and this is going to represent the total time spent on homework or practicing work. Total time on homework. Okay, that's what we're going to put. Now I know that he reads for 20 minutes and practices his math facts for about 5 minutes. And we'll put just math right here. And if you now see, that looks like a little piece of tape. And the total amount of time, which is not really needed, but the reason why people use tape diagrams is it's really easy to now look at the total amount of time. So he spends a total amount of 25 minutes a night on homework altogether. But I want to know how much time he read if he spent 45 minutes on math facts. So I'm going to draw my next tape diagram. It's the same one. I'm going to put here in this box, though, 45 minutes on math. But I do not know how much time was spent reading. But you know what? How does 5 get to 45? I multiply by 9. And I know that these are going to be equivalent ratios. So I do the same thing here to reading. I'm going to multiply that by 9. 20 times 9 gives me 180 minutes. So he spent a total of 180 minutes reading. My answer would be 180 minutes reading. Okay, that is what a tape diagram looks like. And you're going to be watching a video on Khan Academy about tape diagrams and a separate video about double number lines. And here is our double number line problem. In a pizza eating contest, a participant can eat 3 slices of pizza. 3 slices of pizza in 2 minutes. Wow. If he continues at this rate, then how many slices of pizza will he eat in 10 minutes? Okay, so I need to make my double number line. I start with this line and 2 number lines going out. And I'm going to label this one P, and it's going to stand for pizza. And I'm going to label this one M, and it's going to stand for minutes. And now I know with my original ratio that the participant can do 3 slices of pizza every 2 minutes. And that is crazy. And then, so I can keep going. I have 6 slices every 4 minutes, 9 slices every 6 minutes, 12 slices every 8 minutes, 15 slices every 10 minutes. And I stop there because I really don't need to go any farther. It's asking me how many slices of pizza will he eat in 10 minutes. And if I look right here at my double number line, I know for 10 minutes, in 10 minutes, he can have or eat 15 slices, oops, I spelled slices wrong, of pizza. That is crazy. 15 slices of pizza can be eaten in 10 minutes by this participant. And I could keep going if I needed to. And this is the way you work on a double number line. Your next activity is to watch the video on Khan Academy about ratios with tape diagrams.